let us conduct the experimentation using this PWM rectifier trainers. So in the previous video we have seen the different connection method, different operating switches, as well as the different quantities how can we see using the deck. Now we will see the operation of these trainers, or how can we experiment using these trainers. So initially everything should be in turn off condition. Now first we should start our three-phase connection. So I have started our three-phase connection mains. So 400 volt line to line voltage will comes here. After that you should turn on this using this. After that you should turn on this unit. So once this unit is turned on, you can see such display here. So currently DC link voltage ID is 0. This is in off condition. DC link voltage is 140. You can see over the meter also it is the same reading, 140. So here IQ is 0, ID is 1.7, VDC star is 180, phase voltage is 162, DAC1 is having one number, DAC2 is having a 4 number. So now what we will do is we will see currently unit operation is off, so only diodes are conducting. In that condition we will observe the different quantities over the DAC. So what are the before operation and after the operation, what are the quantities are there and how it looks, intermediate control quantities. Here full load condition we have kept currently, that is a 500 watt. Now currently DAC1 is having 1 and DAC2 is having 4. So VA and theta we are observing here. You can see. Now what we will do, we will change this DAC2 number 4 to 5. So I am changing, it is 4 to 5. So it is changed to 5. You can see here IA current is visible. IA current is visible. So IA current is non-linear current. Now we will see IB current. Now I will see IB current. So I will change it to 6. Here you can see it will be 6. Now just wait for a while. 6. So here IB will be there, that is 120 degree shifted from VA voltage. Now I will show the IC. Now this is the IC, which is the 240 degree leg to this voltage IC. Now we will see these are the in the off condition. So currently our unit is off, so this is the non-linear. Now what we will do here, if we turn on this using this key, now unit is turned on. Now DC link voltage will go and follow the reference voltage, and current we can see it becomes sinusoidal. So this is the IC current that we have set, so it becomes sinusoidal. And DC link voltage is 180 reference, it is following the same 180, you can see here. Over meter also it is same, and at input the current becomes sinusoidal. Now let us see other quantity. Now we will see I alpha component. So I need to change DAC2 to 8 number. Now DAC2 I will change to 8 number. I will press it. Now it become 8. Let us see, is it 8 or not. System is on, it is 8. Here you can see I alpha component is in phase. Now I will change it to I beta component. I beta component. So here you can see I beta component is 90 degree leg to I alpha component, and it also 90 degree leg to VA. Now we will see the VA star, that will be the third wave injected type reference wave. So because we are doing the space vector modulation, so you can see this is the VA star, this is the VB star, this is the VC star, and now again this is the VA. This is V alpha, this is V beta. You can see, you can correlate. Now this is the V beta, and again this is the theta. Again let us see VA. So now you can see VA is exactly in phase with the current. So it is the UPF operation of the system. Now if I turn off the system, current become again the non sign. You can see current become non sign. I have off the system. Now I am turning on the system again. Current become again sinusoidal. It is a UPF operation where the DC link voltage follow the reference value that you can see 180. Currently full load condition is there. So you can see now according to this loading condition ID value is 2.8. Now if I reduce this load, ID value reduces. Now you can see still the DC link voltage is regulated to 180. ID values is reduced to some 2.2. Again if I reduce the load, ID value reduces, DC link voltage remain at the reference value. If I reduce further the load, you can see ID value is reduced. So we can see that according to this control system, the ID reference value reduces depending on the load, and ID actual values follows the same. IQ value remains the 0. That shows that the UPF operation is happening. So again I increase the load, sudden change in the load, it follows the load, and DC link voltage is regulated to 180 volt under the dynamic change in the load also. Now let us change the VDC reference. So now I am changing the VDC reference. To increase the VDC reference, we should press this key. So if I press this key, VDC reference is increased to 185. Reference value and actual value are same. I have changed to 190, 195. You can see here I have changed it to 195. Let us put 200 here and observe that on the meter also. Now I kept 200. Here you can see the actual value also following the same 200 volt. So it is also following the reference value that we can see here over the screen. Now if I change to 220 volt, I am further increasing this. This is the 220 volt, you can see. So here 220 volt, in the meter also we are observing the same 220 volt. And the current VA and IA both are the in phase. So this was the operation of this kit that is called as a PWM rectifier kit, where we have seen the load regulation as well as different intermediate control parameters we have observed over the digital oscilloscope. Thank you.